Today we're going to talk about similar figures and scale factors, and our central question is, how are similar figures and scale factors related? Similar figures, they are polygons that are the same shape, but they are different size. Okay, so we have a triangle like this, and then we have a smaller triangle, and they look the same, right? They're the same shape, but they're different size. One is smaller. The corresponding angles to similar figures, those are always going to be congruent. Okay, and we use this symbol right here to say that they are congruent. So basically they're corresponding, they're the same angle. Okay, and corresponding side lengths, they are going to be proportional. Okay, and that proportionality, we're going to use a scale factor to get that proportion. Okay, so basically what it says, angles like this angle and this angle, they would be the same, right? And then this angle and this angle, they would be the same, right? Because this angle right here is 90, and obviously that one would be 90 as well. But the side length, those are not going to be the same. They're just going to be proportional. Okay, so for the proportional part of it, we do have a scale factor, and here we have the ratio of a corresponding side is called a scale factor. Okay, and a scale factor, we usually use SF is the number that is applied to the original figure to create an enlargement or a reduction, okay, to the original figure. So basically you're either going to make it really big, or you're going to make it really small. Okay, so for the scale factor ratio, this is how you get it. You get the new measure, and you divide it by the original measure. Okay, and so let's say you have your scale factor and it's equal to 1. You're not going to change your original, you're not going to change your shapes, right? So you're going to have equal shapes. But if your scale factor is less than 1, then you're going to make a reduction. If your scale factor is greater than 1, then it's going to be an enlargement. Okay, and basically what a reduction is, you're basically going from big to small. And an enlargement is going from small to big. Okay, so let's look at some of these questions. So we have two sections here. We have a section for angles and a section for side lengths, and we have these two triangles here. Okay, in theory, they're going to be similar figures, but we got to prove that they're similar figures first. Okay, so let's go ahead and look at this section right here. So this symbol means angles, and it says angle J is congruent to angle what? Here is angle J. It's 67 degrees, right? It's above the 90 degrees and across from T, right? If we look at this triangle, we can basically see that it just flipped over, right? So our angle that corresponds to J is going to be angle G. So here I'm going to put angle G. And now it says angle J corresponds to, it's congruent to angle G. So they're basically the same angle. Let's go backwards. Let's go from the small triangle to the big. It does say what angle is congruent to angle H. Angle H is here. Our angle that we're looking for, it will be angle T. So angle T is congruent to angle H. And the last one, angle W, is congruent to, obviously, it will be the last one standing, which is K. Okay. Now let's look at the side lengths. So this was angles. This side was angles. And we used congruent for to show their relationship. For side lengths, we just use correspondence, right? Because they're not the same length, right? So let's look at the length of JT. So J to T is the side length 26 centimeters, and it's going from green to blue, right? On the other side, we're going to do the same thing, go to green to blue. And it's going to be that one that's 13 centimeters, right? So we can put JT corresponds to segment GH, and I'm going to put a line over it to say that it's a line segment. TW, let's see. TW goes from blue to that W, and so that's what we're going to do to the other one. Blue to the K. So we got HK as our line segment corresponding to TW. Okay, and then last one, GK will be the green to the K, so it would be the same thing on the other side, so it will be J to W. So JW corresponds to GK. Okay. So let's look at the measures of those, and then we can prove that they are similar figures. So the measure of angle G is right here. We said that it's the same as J. It does not have an angle here, but we know that angles are the same in similar figures. So angle J is 67, so that means angle G is also 67 degrees. Okay. Angle T does not have an angle, and its corresponding angle doesn't have an angle, but we have something else. We have something else in our toolbox that we can use. We know that every single angle inside of a triangle equals to 180 degrees. So I got 67 and 90 in that triangle, so I can do 180. I can get 180, and I can subtract 67 and 90 to get 23. So the angle measure of angle T is going to be 23 degrees. Okay. And lastly, the measure of GK. GK is here, and its corresponding side length is JW. It's not going to be 10, right? Because they're not the same. They're not the same side length because they're proportional, right? So what I'm going to do is I'm going to make a proportional statement saying that, let's look at this. If we have 26 over 13, then we should have, 13 over 26, then we should have whatever x is should be the same, the proportion of 10, right? We're looking at the orange to the red, and that's our proportion, right? So here we're going to put 26x is equal to 13 times 10. We've got 26, solve for x, so we get 13 times 10, we get 130, and we're going to divide that by 26. And we should get x equals 5. So x equals 5 here, the side length GK, and put over here, is going to be 5 centimeters. Okay, so because everything is proportional, like the side lengths are proportional and the angles are the same, we can say over here that the triangle JTW is the same as the triangle, and I'm going to line up the angles. J is the same as G, so I'm going to put GHK. Okay. Let's look at the scale factors real quick. So for the lengths of this figure, we got 12 and 30, right? So from 12 to 30, I want to see what my my enlargement would be. And remember, enlargement is going to be from small to big, right? So my ratio, if you guys remember, is from my new measure to my original measure, right? And then I can put, in this case, my original measure is 12 because we're going from small to big. So I'm going to have 12 over my new measure, which would be 30. Okay, 30 divided by 12 gives you a 2.5. And that makes sense because it's bigger than 1, and if it's bigger than 1, you have an enlargement. Okay, let's look at a reduction. So from big to small, and see what the scale factor of that would be. Okay, so our new, going from original to new, it will be going from big to small. So my new number here would be 12, and my original would be 30. It's basically the reciprocal or the flipped version of enlargement. Okay, so we got 12 divided by 30, we get 0.4. And that does make sense because reductions are always less than 1. Okay, let's look at the widths. The width would be 4 at the small and big, and the big one would be 10. So from small to big, I have 10 over 4, and 10 divided by 4, that's 2.5. Right, the same as the width. Or same as the length, sorry. Okay, let's look at the reduction. So from big to small. So we got 10 at the bottom, 4 at the top, because that's our new over our original. And we get 4 over 10, which is the same as 0.4. Right, same as the length. Okay, and if we did everything right, and these are similar figures, the height should have the same scale factor. Okay, but let's go ahead and make sure. So from small to big, we have our original would be 6, and our new would be 15. So we got 15 divided by 6. Put that in the calculator, you get 2.5, and yes, it is. They are similar figures, but let's go ahead and do the reduction. So the reciprocal, 6 over 15, or the new, which would be the small, right? The small cube. And 6 divided by 15 is 0.4. So that means that these two cubes are similar figures because they have the same scale factors when you enlarge it in length, width, and height. And in reduction, they have the same scale factor when you make it from big to small.